Lesson 9.1 is all about powers and exponents. So there's a couple warm-up problems here. You'll want to pause, try these on your own, then we'll go through them. The first one says to evaluate, which means to solve, and we're going to have to use order of operations here on the top and on the bottom. So I'm going to want to do the parentheses first on the top. So 4 times 10 plus 2 is 12. And then same thing with the bottom. We want to do the parentheses first. 24 divided by 3 is 8. And now they're both multiplication, so I can solve. 4 times 12 gets me 48. And 2 times 8 gets me 16. Well, 48 divided by 16 is 3. And then this next one here, again, we're going to use order of operation. So parentheses first. 18 minus 6 gives me 12. Plus, and then I'm going to do this multiplication here. 2 times 4 is 8. And then multiply that all by 3. 12 plus 8 is 20. 20 multiplied by 3 gives me 60. Okay, so exponents can be written, ignore these arrows, but exponents can be written as a number to a power. So 9 times 9 times 9 can also be written as 9 to the third power. So whatever the power is, 9 to the fifth power, that would be 9 5 times. And 9 times 9 times 9 is 729. So for these examples, we're going to write the expression using exponents. So it's not actually asking us to solve. It's just asking us to rewrite it using an exponent instead of writing it out like this. So here we have -6 times -6 times -6 times -6. So in parentheses, it's super important that you include parentheses. -6 to the, and there's 1, 2, 3, 4. So I would write that as -6 to the fourth power. If you forget the parentheses and just do -6 to the fourth power, what would happen here is you would do just 6 to the fourth power and then add on a negative, which would change your answer. So remember to do parentheses when the number is inside parentheses. Okay, then this one is W times W times W times W. So that would be W to the fourth power because there's 4 W's. The third example would be 1/3. Again, I'm keeping the parentheses there, to the 1, 2, 3, 4, 5 fifth power because there's 5 1/3. So 0 exponents are actually kind of nice because anything to the 0 power is 1. So 1,238,569 to the 0 power, 1. Anything to the 0 power is 1. 50 to the 0 power, 1. N to the 0 power, 1. Because no matter what number we would plug in for n, anything raised to the 0 power is 1. So some examples here. This one says evaluate -2 to the fifth power. -2 to the fifth power means we're going to take -2 times -2 times -2 times -2 times -2. So -2 5 times. So now I'm going to solve this. -2 times -2 would be +4. +4 times -2 would be -8. -8 times -2 would be +16. And then +16 times -2 would be -32. So our answer is -32. This next one, 3/5 to the third power, that means we take 3/5 times 3/5 times 3/5. Remember that when we multiply fractions, we multiply the numerators, multiply the denominators. So 3 times 3 times 3 is 27. And then for the bottom, 5 times 5 is 25. 25 times 25 is 125. So I get 27 over 125. So just some review on order of operations. Remember to use PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction. The first thing simplify the expressions inside the grouping symbol. So that's where the parentheses comes in. We do whatever's inside the parentheses. Then we want to evaluate all powers. Powers are the same thing as exponents, so that's where we do the exponents. Then we do multiplication and division. Then we do addition and subtraction, remembering that we need to do that from left to right, in order from left to right. So to practice that, the first example is 6 times 4 plus 8 to the 0 power. So first thing is parentheses. Yes, there's parentheses here, but there's nothing to do inside of the parentheses. So then I go on to exponents. Well, 8 to the 0 power, remember anything to the 0 power is 1. So this is going to be something plus 1. Then we move on to multiplication. 6 times 4 is 24. And now we can add. 24 plus 1 is 25. The next one, 3 times 4 plus 2 to the second power divided by 3 squared. Well, remember, P parentheses first. So 4 plus 2 is 6. And then my next thing is exponents. So I'm going to take 3 times and then 6 squared. 6 times 6 would be 36. Divided by, and then that's another exponent, 3 squared, 3 times 3, 9. Don't make the mistake of doing 6 times 2 and 3 times 2. That's not what that's telling us to do. It's telling us to take 6 2 times, 6 times 6. All right, now we want to do multiplication before we do division. 3 times 36 gives me 108. And then we divide that by 9. 108 divided by 9. Let's see, 9 goes into 10 once. Subtract. Get 18. 9 goes into 18 twice. So 108 divided by 9 gives me 12. This says to evaluate each expression if y is -2 and z is 4. So I'm going to plug those numbers in for the variable. So I'm going to rewrite this as 3 times 4 squared plus 4, because z is 4. Okay, so first I need to do parentheses, and inside the parentheses there's an exponent, so I'm going to do that first. So 3 times 4 would be 16, plus 4. Then I still want to do what's in parentheses. 16 plus 4 is 20. And then I take 3 times 20, which is 60. All right, then we have zy squared. So z is 4. And then I'm going to do parentheses to show multiplication. Y is -2 squared. So there is parentheses, but that parentheses right now is representing multiplication. It's not representing like something that we need to solve inside of it. So I need to do exponents first. I'm going to take -2 squared. -2 times -2 would be +4. So this would be 4 times 4. And 4 times 4 I know is 16. So notice too that this would be different if we did the multiplication before we did the exponents. So if we took 4 times -2 first, 4 times -2 would be -8. And then if we squared that, we'd get an answer of +64. Those are not even close to the same. So make sure you do exponents before you multiply. Complete the statement using less than, greater than, or equal to 5 squared and 4 to the 3rd power. So 5 squared would be 5 times 5, which is 25. And 4 to the 3rd power would be 4 times 4 times 4. Well, 4 times 4 is 16, and 16 times 4 is 64. So 5 squared is less than 4 to the 3rd power. Okay, word problem here. It says to find the distance an object falls, use the expression 16t squared, where t is the time in seconds that the object has fallen. If an egg hits the ground in 3 seconds, from what height did you drop the egg? So we know height equals 16t squared. And the time was 3. So I'm going to plug in 3 for t. So h equals 16 times 3 squared. Again, we are going to do the exponent first. So 3 squared first. 3 times 3 is 9. So I take 16 times 9, and that equals h. Well, 16 times 9. 9 times 6 is 54. 9 times 1 is 9. Plus 5 is 144. So the height is 144, and it doesn't, this problem's kind of weird. It doesn't even give us like a label, so we'll just say units? Question mark? All right, the next few are going to be practice problems that you would see on like a standardized test. So no calculator on this one, but it says to simplify. So 3 times 2.25 to the second power. So remember, exponents come first before multiplication. So I need to take 2.25 times itself. I'm going to bump the decimals to the right. Total of 4 times. And then I'm going to multiply here. 225 times 225. And hopefully you can pause this and get it on your own. But you should get an answer of 50,625. And then we have to bring the decimal back 4 places. So it would be 5.0625. And then we have to multiply that by 3. So we take 5 and 625 10,000ths times 3. Three times 5 is 15. 3 times 2 is 6, plus 1 is 7. 3 times 6 is 18. 3 times 0 is 0 plus 1. 3 times 5 is 15. Bring that back 3 times. And our answer is 15 and 1,875 10,000ths. Okay, this one says, what is the value of 4t squared plus 6r minus tr when t equals -3 and r equals 5? So I'm going to plug in these values. So we have 4 times -3 squared plus 6 times 5 minus -3 times 5. All right, super important here that we use our order of operations. First thing is parentheses, and that's when we have something to solve within parentheses. Nothing here. These all represent multiplication. So the next thing would be exponents. So -3 squared is -3 times -3, which would be +9. So here we have 4 times 9 plus 6 times 5 minus -3 times 5. Okay? Now, we're going to move on to multiplication. So there's many different things we can multiply here. 4 times 9, let's see, we have 36 plus 6 times 5 is 30. Minus -3 times 5 would be -15. And we know that when there's 2 negatives, we want to add up, so that becomes plus. When I add these together, 36 plus 30 plus 15 should get an answer of 81. Okay, and then the next one here, again, no calculator, but it says use the numbers below to answer question 6. And question 6 says which shows the numbers ordered from least to greatest. So 6 to the first power would just be 6. 3 to the second power would be 3 times 3, which is 9. 2 to the third power would be 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. And then 1 to the 7th power would be 1 times 1 times 1 times 1 times 1 times 1 times 1, which would just be 1. So from least to greatest, we would have 1/7, then we would have 6 to the first power, then 2 to the third, then 3 squared. So it looks like B would be our answer. Okay, so then this moves into the 9.2. I know it's a long lesson. So just some vocab, prime numbers. I know we've talked about this before, but prime numbers are whole numbers that have exactly 2 factors. So 1 in itself. So like 17 can't be divided by anything but 1 in itself. So it's prime. Composite numbers are numbers that have more than 2 factors. And then factors are numbers that are multiplied to form a product. So like factors of 4 would be 2 and 2 because those can be multiplied together to form 4. So some practice with that. Actually, before we practice with that, just some things to know. A number is divisible by 2 if it's one's digit is even. That'd be a good thing to write down. It's divisible by 3 if the sum of the digits is divisible by 3. It's divisible by 10 if the one's digit is 0. And it's divisible by 5 if the one's digit is a 0 or a 5. So looking at these numbers, it says find the factors of each number and tell if the number is prime or composite. So 18, definitely composite. I'm going to do a C for composite because it definitely has more than just those 2 factors of 1 and 18. So here's how I do factors. 1 and 18. And you might have heard these as like factor rainbows. But then I think, okay, 2. Yes, 18 is divisible by 2. 2 times 9 is 18. Then I think about 3. Yes, 18 is divisible by 3. 3 times 6 gets me to 9. Not divisible by 4, not divisible by 5. It is divisible by 6, so that tells me where I end. Okay, whenever I reach that number, we're good. 31. Can 31 be divided by anything? No, I don't think it can. So it would be prime, which means its factors are just 1 and 31. And then 49 is composite because it has more than just those 2 factors, 1 and 49. 2, no. 3, good way to check if it's divisible by 3 is adding the digits together. So 4 plus 9. 4 plus 9 is 13. If that's divisible by 3, then the answer is divisible by 3. So it's not. 5, no. 6, no. 7, yes. 7 times 7 is 49, but I don't have to write that twice. And that tells me where I end. Because I can't go any bigger than that. So 1, 7, and 49. Prime factorization is writing a number as a product of all prime numbers. So we're going to practice that here. The prime factorization of 450. So 450 breaks down into 30 times 15. Those are not prime. 30 breaks into 6 times 5. 5 is prime. 6 is not, so that breaks into 2 and 3. 15 breaks into 3 and 5. Those are both prime. So I look at my numbers. Once I get to all primes, I look at those, and then I write them from least to greatest.
Hello?
Hey, Inga.
Hi, I'm confused on number 11.
Number 11. All right, let me pull it up. Okay, what about number 11? So remember we have to follow those steps of add up. So did you add up?
Yep.
Okay.
Uh-huh.
Then there's nothing we can distribute. Are there any like terms we can combine?
Okay, yep, now I get it. I don't know why it was confusing to me, but I guess it was.
That's okay, you just had a little brain fart?
Uh-huh.
That happens. Do you need any other help with that problem, or you think you got it?
No, I got it.
Okay, sounds good.
Bye.
Bye. So once we get it broken down into all prime numbers, we're going to write those from least to greatest. So there's 1, 2, then there's, so we write this as 2 times 3 times 3 times 5 times 5. And we can actually write that using exponents. So it would be 2, because there's only 1 2, 3 squared, because there's 2 3s, and 5 squared, because there's 2 5s. So then if we practice that, 540. Think of two numbers that it can be divided by. Well, I think of 10 and 54. Well, both of those are not prime, so we need to get them to be prime. 10 can be 5 times 2. Those are both prime, so I'm done with those. 54, let's see, we can be broken down to 9 and 6. 9 can be broken down into 3 times 3. 6 can be broken down into 3 times 2, and those are all prime. So then, let's see, I have 2 2s, so I write that as 2 squared. I have 3 3s, so 3 to the 3rd power, and I have 1 5. And there's my answer. So more vocab, a monomial is a number, a variable, or the product of a number and one or more variables raised to whole number powers. So it has to be, there's no like addition, subtraction, just that multiplication. So like 25mn squared, x, 8x, those are examples of monomials. Not monomials would be 25 plus mn, x squared plus y squared, because there's addition in there. So to factor monomials, we break down the number into its prime factorization and then write each variable as a product with the power of 1. So we cannot use exponents in this factoring of monomials. So when we look at 16a squared b, well, we can factor this down. 16 can be factored. Let's see, we have 4 and 4, which is 2 and 2, 2 and 2. A squared can be factored down into a times a, and b can't be factored down. So those are all our primes factored down. So we write that out without exponents. So 2 times 2 times 2 times 2 times a times b. And there we go. Okay, then we have negative 36 s to the 4th times t. So negative 36 can be broken down into negative 1 and 36. This can be broken down into 6 times 6, which can be broken down into 3 times 2, 3 times 2. And then s to the 4th would be s squared, so it'd be 4 s's, and then a t. So I would write this as negative 1 times 2 times 2 times 3 times 3, and then times s times s times s times s times t.